Okay, now we can share.
Question.
Yes,
Do we have any upcoming homeworks?
I just update the due dates for them today.
Okay.
So it's three, I think. We're done with 1 and 2, and three. Let me just double check. Yep, three is available, and the due date it's going to be 20th of September.
Okay.
Okay. Let's go back here to our no. So last class we talked about the wrapper classes, and we said for the primitive data type, integer, double, character, long, float, we have classes, and we said we have a class for integer, and we have a class called double, class called character, and those classes were simply created to add some level of functionality to the primitive data types, because we know primitive data types are just variables to store values, but there are no methods associated with that data type. So I mean Java Society programmers decided that we'll create some group of classes, we're going to call them wrappers, to provide some level of functionality. And we said the integer, the double, and the character class, the book that we're using decided not to talk about it that much. So I'm just going to respect that for now. Maybe later we'll have a whole chapter to talk about this character class, because there is a lot inside the character class that you want to know. I'm pretty sure that it's going to be mentioned later. So we focused on the integer class and the double class, and we said for those two classes, we can simply convert any string that only contains numerical values into integers and into doubles if we are following the right format. And one of the reasons why we have those two methods, and by the way, if you want to create it by yourself, we will learn later that you can do it by yourself if you don't want to use the one that's available, but that doesn't make sense. The idea here is that every time you ask the user to enter something, especially if you're asking the user to enter a numerical value, and the user by mistake will enter a character, an alphabetic character, that will lead for the program to crash. And this is not what we want. So instead of asking the user to enter the number in a form of a character, sorry, in the form of a numerical value, we ask the user to enter it as in a form of a string. And then after that, we take the string and we perform some test on that string to make sure that only digits are included. And after that, we can, with confidence, convert it into an integer or convert it to a double. Now, one thing that I didn't mention last class is that in addition to having those two methods, and of course the toString method would simply do the opposite, converting the integer into a string, we have some constant variables that are associated with those data types. And I'm just going to show you one of them, and of course it simply will be applied to all of them. So I'm just going to come here and I will say integer dot max underscore value. I forgot the semicolon here. And that should show me the maximum value for an integer. And I can do the same thing for a double if I want to. Let me just copy that and put it here. So just in case you are wondering what will be the maximum value you can actually you can store in an integer. And same thing for double, you'll be able to see that. I'm just going to come here and comment this section because I don't want to see the input section of it. And I will talk about this later. So let me just convert it to a comment. And you know what, let's just convert everything to a comment and just keep what we need to do today alive. And here we go. So let's go with this, give this a try. And here we go. So this is the maximum integer you can store value, and this is the maximum double value you can store. It's simply 1.797, all these numbers multiplied by 10 to the power of 308. So that's a huge and big value. So this is the only part that we didn't talk about last class. After this part in the PowerPoint and the book that we're using, the book start talking about the string class. And after that, the book decided to go and talk about the print format. Now, I want to remind you that when we talked about the Sarah project, we explained what's the printf method. There was only one part that I didn't mention. So I'm going to go through that print format again right in this class, just to give you an idea about how does it work. The idea here is very simple. We already, as I said, we had an idea about what is the print format and how does it work. But today we're just going to go through it a little bit with more details. So I'll just keep this as it is. Let me just go down here and let me bring one of those print format methods. Now, I'm just going to remind you about what we did last time. We said if you want to control how your output are going to be, we use a print format. And here, what I'm going to come here and put a 12. I'm going to put here, let's say 12, something really big, something like that. That's an integer. I'm going to put another number, for example, 0.00002. And I will put a string. I'll put Adam Smith. So those are my variables. Now let's just go ahead and talk about how do we print them. Since 12 is an integer, we said you'd use %d. I'll put a space. And then after that, since this is a decimal point, so we put a %f, but you're going to have to tell me how many decimal points you want to see. For example, I will just say 0.2. I'll put 0. So that simply means I want to see the whole number with 2 decimal points. After that, for the second one, I can do the following. This is something new. I'll put E. Okay. So E simply means print that number in the scientific notation. And then finally, after that, we have an S, so %S. And let's give this a try. If I run it, here it is. You can see here, this is 12, as it is. This is my other float number, and this is my float number. Look, it's printed in the form of a scientific notation. And then Adam Smith as it is. Now, we said, if you put a value here, like for 10, that will simply mean there will be 10 spaces reserved for that number to be printed. It's called the width of that number. So I'm just going to go ahead and put it. Now, if I print this way, you'll see that all the numbers are simply printed. There are 10 spaces here, 10 spaces here. I'm going to increase this value here. Instead of 10, let's make it a little bit big. I'll make it 15, and this one to be 15 as well. And Adam Smith, let's just put it as 15 as well. Let's go give it a try. And you can see here now we got 10 spaces, 15 space, 15 space, and 15 space. Now we said if you want it to be adjusted to the left, you just put a hyphen here. And you put a hyphen here and put a hyphen here, and then all of them are just simply going to be adjusted to the left, which simply, again, here we go. This is how it's going to look like. So you got 10 here, 15 here, 15 here, and 15 here for these values. Okay, so we covered that part. There are a few parts that we didn't cover, and I'm going to go through them today. One of them is the comma here. Let me take this number as an example here. This 124,556. If I want to see a comma here printed on the screen, all I have to do is to come here after the hyphen and put a comma. And I want you to pay attention to what's going to happen to this number here. And you can see here a comma has been added. So that's, again, a very, very important fact here. If I have a negative value, for example, let's go and put 12. Before I put 12 into negative value, let me just take this negative away. I want it to go back to its original adjustment. So it's going to be all the way to the right, all the values to the right. Now, if I want to see this extra space that I have here covered or filled with 0, and we know any 0 to the leftover number has no values, all you have to do is just put 0 here. If you put 0 here, put 0 here, and put 0 here. I don't, it's this 0 probably would not work for the string, but let's just give it a try before we give it. And here, look at this. All these extra spaces now are filled with zeros. And the extra spaces that you have here are filled with zeros. Now I'm just going to go here for the fact of testing to put 0 with a string. I know it should not print anything. Yep, it was not accepted. You cannot use the 0 with the strings. So that makes sense. Let's run it again. And you can see here I got the zeros. Now, let's just imagine 12 here was a negative 12. If you run it, it would print it as negative 12. Again, I'm just reading the documentary here of Java. They said if you have a negative number and you want that negative number to not be a negative number and you want it to be presented between parentheses, all you have to do is to come here and put an open parenthesis here. If you do that, the negative sign will not be shown and the whole number is going to be covered with parentheses, opening and closing. So you can see here, now it's covered with an open parenthesis and closing parenthesis. Now, I'll be honest, I really don't know why or when would I actually want to do that. When would I want to actually replace the negative sign with a parentheses? Maybe, I'm just guessing, maybe if I wanted to look like this. That's, again, just a guess. I'm hearing someone.
Oh yes. So that I do accounting as part of my job. That's an accounting thing.
Okay.
When you have a credit on a ledger, you record it as in parentheses.
Okay.
Can you get things to notate in like a currency format, like add a dollar sign to the front of?
Yeah, but just put it that way here, for example.
Oh.
It should print it. I don't know why would it not.
Okay. All
Here
right.
it is. Again, whatever you want it to be printed, it will be printed. All you have to care about is what you have after the dollar sign. Sorry, the percentage sign. So those are going to have an effect on what's supposed to be printed. But again, if you want to print anything, you should have no issues. I'm just going to show you if I come here and put an asterisk, because asterisk has no values associated with the percentage, it's simply just going to print it as it is. So that simply applied to the dollar sign. You can put it before, you can put it after, you can put it whatever you want to put it.
Okay, thank you.
You're welcome. So this is the only part that was missing from the printf that we didn't cover last class. And I'm really, really glad that the book that we're using didn't decide to wait that long to talk about the printf. So we already have the information in our head. This is just a refreshment. Okay, now, with that being said, we can move on and talking about the last part, which is very, very important part. By the way, if you go and read the PowerPoint, there's an example about the lottery. I looked at that example, and to be honest, one of the things that I didn't like about this example is that give me a hint. When you ask for a hint, the answer for that give me a hint is actually giving the winning number. So that didn't make that much of sense to me. But again, it's a very, very straightforward game that you can look at it and see how does it work. Now, let's move on and talk about strings. Strings are a very, very, very important non-primitive data type in Java and in many other programming languages. And a string is simply a collection of characters. That's something we already know. To create a string in Java, we have multiple ways to do that. The book that we're using here, and I'm pretty sure he's going to talk about different methods later, but for now, he's just going with the traditional way to create a string. And then after that, I'm just going to mention different types of strings that we might learn about later. So how do we create a string? Very, very straightforward. String, name. Let's go call name one. And then I'll just come here and say Adam, for example. And I'll put semicolon. So this is how we've been creating strings and names so far. Here's what I can do. strings also could be created using this way. And I'll come here and put, for example, Smith. So here's another way to create a string. Now, I would argue that this is the original way to create a string. And just because the strings are really, really very, very important, not primitive data type, latest version of Java decided to change the way to create a string to make it in this format, so it will look like it's a primitive data type. But this is, again, how we create strings. Now, why strings are important and different than their primitive data types. This is what I'm going to cover right now because it's very, very important to understand that concept. But again, before I get to that point, a fact that we should know again at the beginning that strings are non-primitive data types, and a string by itself, the class string, comes as a part of the java.lang.object class that is going to be preloaded with your project. So you don't need to import string when you start your work. It's going to be loaded just like how the math was loaded automatically without the need for you to import math. Okay, now with that being said, with the string class comes a lot of methods. Processing strings is very, very important because information could be stored in a form of numbers and in form of strings. And when you have the data and the information is stored in a form of strings, it's very, very important. Processing data is very simple and very easy. Just numbers, you're going to multiply them, divide them, apply some math functions, add them, and that will be it. But strings, processing strings is a little bit more complicated, of course, than processing numerical values. So the string class comes with a long list of methods, and we are going to go through some of them, not all of them. And before I say anything, I'm going to jump into the most important method in strings. And this thing needs a good understanding because this is one of those questions that you will be asked about in interviews. Now, here's what you need to understand. And I wish I can draw something in front of you so you'll catch it, but I'm going to try to describe it in words, and I want your brain to imagine what's going on. Let's take an integer x as an example and assign it to 10. And let's take another integer of y and assign it to 10. Now, here's some facts we need to know about those two variables. X and Y are primitive data types. Primitive data types are part of the programming language. And the way the compiler will work with the operating system to handle primitive data types goes like the following. Whenever you create an integer variable, a space inside the memory is going to be reserved for that variable and is going to store whatever the value you want it to be stored at. So space inside the memory will store the value of 10, and the space of the memory, other space of the memory will store a value of 10, but the first one is going to be referenced by X, the other one is going to be referenced by Y. Very, very straightforward, very simple, no big deal. And you know what? I think I can make it a little bit easier to understand. Let me just switch my sharing screen. And I'm just going to put a table here so you'll understand what I'm saying. No. Let's go ahead and create a table. And I'm going to reduce that table like this. And what I want you to know here is very simple. Let's see if I can draw here. Can I? Yeah, I can. Oh, God. I'm so happy. So this, for example, is going to be called X, and you're going to put 10 inside X. Now, that's not a 10. So sorry for my skills. Here we go. This is 10. And Y inside the memory is going to reserve a space inside the memory, and the value of 10 is going to be stored here. Now, you understand the memory locations based on their references. But in reality, every single memory location has an address, And those addresses are this hexadecimal numbers, and they are very, very long addresses. But for simplicity, we can just refer to this one, for example, as 1, 2, 3A. And this one, for example, is 1, 2, 3, D, for example. Those are hexadecimal numbering systems. Hexadecimal numbering, sorry. So this is how Java handled primitive data types. Now the question is, and let me switch to Eclipse. How would Java deal and handle a case like the one I'm going to show you here? Let me see here. No chat. Okay. If I create a string, you know what? I did create a string here. Let's create name1 as Adam and name2 as Adam. Okay. So I have two strings, non-primitive data types. One of them is called name1 and the other one's called name2. Both of them hold the value of Adam. So let's go ahead and see how that will work. I'm going to insert a table again. Oops, in the wrong place. Let's insert a table. Okay. How do I take this out? Let me just create a new page.
I think you're still on Eclipse. I don't know if you're trying to swap back
Oh,
to
sorry,
the
sorry. Yes,
document.
yes. Okay, I forgot. Let me swipe. Control Z, Control Z. Do you guys see it now?
Yeah.
Yeah.
Okay, let me just take whatever I just did here out. I'm pretty new to this iMac thing. Okay, so here we go. This is my memory again. Here's how it's going to work. Very, very important to understand. I'm going to come here and I'm going to store the value of Adam. Okay. Now this memory location hold a value. Sorry, has an address. And let's say the address is 18A C. Just imagine that's the memory location of this value. How would Java handle the situation? Java would do the following. Java will create a space and is going to call it name1. And name1 is going to hold the address of Adam. So here in this area, we're going to store 18018A C. So instead of having your primitive data type or the reference pointing or referencing the actual value of Adam, it's simply going to reference a memory location that holds the address of Adam. And now you have the right to ask, why would the computer system do it that way? Now, here's the reason why Java would do it that way. Because when you created name2, Java realized that there's a space that hold the value Adam available already. So instead of reserving a new space to store the exact same value, Java will simply store 18, look at this, 18A C. So you can see here, name1 is referencing a space inside the memory which hold the address of the object.
I have a question.
Yes.
So name1 and name2 both hold the address of Adam, right?
Yes. Yes.
If you only have name1, will name1 point to the address, or will it just like
No, it would do the same thing. Like if name1, name2 doesn't exist, it will do the same thing.
Okay.
Yes. And I'm going to continue. I'm not done yet, by the way. So here we go. So name1 and name2, both of them are referencing spaces inside the memory. And for each one of those spaces is simply holding the value and the address, of the object Adam. Why do we do that? Why does Java do that? Because Java is trying to save some time. Objects usually reserve a lot of space. So instead of me, just because there's a possibility that two objects may hold the same value, then I'm going to use this technique to save some memory. But if, let me just tell you something, if all your strings are holding different values, I will guarantee you each one of those strings will simply perform the same exact operation. There will be a space for the object. The address of that object is simply going to be used to store for the name for the primitive data type. Is that clear?
Yeah.
Okay. Now, there is a big issue that is going to come next. The next issue is going to be as following. And I'm just going to extend the view here. Imagine you decided that you want to know name 2. I'm going to change it to Smith. So what's going to happen in this case? Since you decided to change the value of name 2, the compiler will simply look for a new space inside the memory, create the object, and put a Smith in it. Okay? And then after that, let's say the memory location address here is 1111. Then what's going to happen here? Simply the address that you have here will be replaced with 1111. That's if you decided to change the value of Smith, value of name 2. So simply again, a new object was created with a new memory location, and then that memory location updated whatever name 2 was referencing me. Is this part clear? Because what's coming next is going to be a little bit confusing. Okay, there's a question here. Do you mean name 1 can be used to access to name 2? Again, both variables referencing the same spot inside the memory. And I want you to pay attention here because to answer your question, I'm coming next to answer that question. So you're telling me, do you mean name 1 can be used to access name 2? I would say yes and no. Simply, if you're trying to print name 1 and print name 2, both of them are referencing the same space inside the memory when they share the same value. But the moment you change the value of name 2, notice that I created a new space and I stored the new value and I used the reference for that, the address of that space for name 2. Now here, this is the part that it will make it a little bit maybe more understandable. So if I come here and do the following, this is very, very important. Name 1 equal, and let's change it to John. This is extremely important to understand. Now, you may think, let me just put it this way, you may think that Java simply will come to Adam and erase it and replace it with John. But that's not what's going to happen. And let me show you what's going to happen. What's going to happen that a new space inside the memory is going to be reserved. Let's just put it here, for example. And John is going to be stored here. And imagine that the address of John was simply 222. And at that point, what's going to happen? This area here is going to be changed to what we call, what we have 2, 2, and 2. Okay? So let me just put this as a fact. Java cannot change the value of non-primitive data types. What is that supposed to mean? It simply means if you have a primitive data type, for example, inside the memory, let's say X is an integer and X hold the value of 10, and then you decided to change 10 to be, for example, 100, then yes, because it's a primitive data type, Java will be able to erase the 10 and replace it with 100. But with non-primitive data types, Java would not be able to erase to replace any value, to change any value. any non-primitive data types are simply what we call I'm trying to remember. You just can't change the values. Like once it's created, it's created. Now you may ask the question, so if I change the values of name 2 to Smith and name 1 to John, what's going to happen to this value? Here's a cool feature that Java has. Java has what we call a garbage collector. Think about a garbage collector as a person who is carrying a cleaning product and running after you, cleaning every area after you're done with it. So immediately when Adam is not used anymore, Java will immediately come and erase that area and free it so it will be used later. This is how Java handle non-primitive data types. You cannot change their values. What you can do is to create a new area in the memory with new values and refresh the memory location addresses, and whatever you're not using anymore, immediately the garbage collector and come and clean them. Now, why am I telling you all this? I'm telling you this for a single reason, and I'm going to go to Eclipse to explain that reason. Let's get back here to this example. Name 1 equals Adam and name 2 equal Adam. Now, we learned about how do you compare two values. For example, I'm just going to come here and say if name 1 double equal name 2. If that's the case, just system.out.print line. And I'm just going to type same. Okay, now this is not acceptable to compare for equality. Let me just put it that way. So what do I mean by that? When you have a non-primitive data type and another non-primitive data type, and you want to compare them to each other, by using the double equal sign, you are simply asking this question. Are those two strings referencing the same space in the memory? I think I'm not spelling this right. Nope. Nope. Okay. Let's keep it rough. Are those two strings referencing the same space inside the memory? That is the question that we are asking here. We're not asking if Adam equal Adam. We're asking, is name 1 holding an address that is equal to the address held by name 2? By default, that will be true if the values were true. But again, technically, we are not asking for equality of the quantity of what's held by those two strings. So the question that you may ask, how do I do a comparison then? And to answer that question, this is how we do it. We type if, and I want you to pay attention to what I'm going to do. Name 1 dot equals name 2. And then after that, let's just print same. Now, you may ask, well, will the results be different? And the answer would be no. It's both of them are going to be true. Both of them are going to show me same. But same here simply means both of these two objects are referencing the same spot inside the memory. This one, he's actually comparing between the values. So let me just run it, and you'll see that I will get same both cases. Okay, why is it not printing anything? Oh, here it is. This is the same. Let me just go back here, print \n, and I'm going to put an asterisk here. Let me run it. So I think I should get two sames. So I got only one same. And the same that I'm getting is simply this one, not this one. And I think maybe because I'm using this new string. Let me just take this out. Let's give it a try again. And now I got them both. Okay. So whenever you want to compare two strings, make sure that you don't use a double equal. Make sure you use dot equals. Now we have another case, for example, that will make more sense. If I put atoms with an uppercase, with lowercase, one of them, of course, none of them are going to be true, because if I give this a try, it's going to give me false for both of them. Actually, because I have nothing here, so it's not going to reprint anything. But here, if I type equals, ignore case. If you use this method, equal ignore case, you can actually compare two strings despite if they have uppercases, lower cases. So it's showing me same for this one here. Now, this is how strings works. If you want to compare them, you go with this case here, equal, ignore the case, or equals if you want to. We have another types of strings. One of them is called the string builder and string buffer. They're a little bit more complicated than this regular string. Creating a string is way complicated comparing to here. For example, with the regular strings that I did here, I can come here. I can come here and change the value if I want later. For example, I can come here and say name 2 equal Smith again. So that will work. But with the string builder and string buffer, you can't just assign values to it. You're going to have to call methods to get the job done. And the only benefits that I can think about those two strings are more suitable for multi-threads. That's what I heard, what I read about. And they're more secure compared to the regular string. If we have a chapter about that, we'll get into those details. But for now, we're just gonna have to stick with knowing how strings are working. Now,
So
yes,
I have a question.
yes.
Non-primitive types have to be declared with the besides string, non-primitive types have to be declared with like the like scanner name equals new scanner.
Scanner, by the way, is a non-primitive data type.
Yeah.
Yes.
So like non-primitive data types have to do that except string.
Yes.
String doesn't have to do that even though it's non-primitive, right?
Your voice was cutting. What's the last one?
String doesn't have to be initiated like that.
You can go
Equals
this way. It will work too. Let me just put it this way.
No, I'm asking all other non-primitive data types have to do that.
Every
right?
non-primitive data type will be created this way.
Okay.
The only one that is different is string, because they changed. Again, this is just the fact that they changed the appearance, but deep down inside, this is how strings are supposed to be created.
Okay.
Now, for some reason, and this is probably something new in Java, because I think I should be able to see this as same. And I'm just going to put another sign here. So when you create strings using the new string method this way, this is becoming false. This is not acceptable for some reason. But again, the last time I read, and again, if I just take those away, again, here we go. Now it's working. So it looks like there's some update happened to Java that is yes.
Yes, you said with the non-primitive data type having the same value, they have different addresses. So why the two statement, the two if statement are giving us the same value?
You mean both of them are true?
I was expecting the first one to be false because they don't have the same memory address.
Oh, when I put it as lowercase a, I changed it to an uppercase a. Yes, that's the thing that I need to go and dig and see, because again, if you put it this way, whatever I explained in the Word document will be acceptable and it will be true. And that's why, again, when you put it this way, you'll notice that I'll get two sames, one with an asterisk and one with the, I don't know what this is called. So you can see that if you put it this way, but if you just change this one to use the new keyword, it's going to go ahead and reserve two different spaces for each string.
Okay.
Do you see what I mean?
Yes.
Okay. So this
Yes.
method here, again, both of those names are going to reserve the same spot inside the memory. But if I go ahead and use a new string this way, each one of them, even though they actually have the same value, but they will reference different spaces inside the memory. And that's why, let's just put it this way. That's why if I put it this way, look here, he's not showing me this. You see this part? He's not
Okay.
showing me this. Now we know this is Adam and this is Adam. So isn't that supposed to show me this message printed on the screen? But as I said, because this is a string and this is a string, he's not comparing, look at this, he's not comparing the values, he's comparing the addresses. And because we are using, again, this technique with the new keyword here, then two different spaces are going to be reserved inside the memory. So
Okay.
if I want to put it as a bottom line, whenever you want to compare two strings, do not use this. We rarely, where we want to compare and ask the question of if two strings are referencing the same space inside the memory. Usually we would like to compare them, compare the quantity of them. So whenever it comes to quantity comparison, you have to go and use equals or equals ignore case. Okay, so let me keep going here. We have three methods that we're going to cover here about strings. I'm going to go one by one. Let's create a string str, and in this str, I'm just going to put a message here. Hello, JCCC. This is a Java class. So I got a long string. Let's just put a comma here. So what can we do here? First of all, there's one method that is extremely important, which is the length. And the length simply would tell you how many characters do you have in that string. So let's go ahead and put length. And I think it doesn't work that way. You have to come here and type str.length. Put in parentheses and close it, put a semicolon. This would tell you how many characters you have here. We have another method. It's called character at. Let me just copy that. And by the way, the list of methods goes way beyond what the book we're covering is telling us about. But let me just go here, put character, C-H-A-R, at. And here, between the parentheses, let's see, he's going to tell me a character at index of, let's say, 7. So let's go here. This is 0. This is 1. This is 2. This is 3. This is 4. This is 6. This is 7. It should print 7. What you should know about strings, that every single character could be described by its location in the string. So every single character has what we call an index. An index represents its location in the string. We always count from 0. So H will have an index of 0, 1, 2, 3, 4, 5. Wait a minute. 0, 1, 2, 3, 4, 5, 6. So C is going to be printed here. Let me just change that to be 6 because I want to see J. Okay, so that's character at. The other method that we're going to cover is index. Okay, so let's go ahead and try the index. Control V, and we'll come here and type index off. The book doesn't actually show us. So what you need to do here, you need to give me a character and tell me, for example, if I go with C, uppercase C. Is that uppercase C? Yeah, uppercase C. So he's going to tell me where is the existence of C. And as you can see here, we have multiple C's here. So he's simply going to tell you where is the existence of the first C. Let me just give this a run. And here we go. We got 32 characters. J is what I was looking for. And then C is located at index 7. So those are the methods. Now, those methods are not the most important methods that we have here. And by the way, index of C, we can also add something to it to ask him, for example, to look for, let's see here, what do we have? I want to put an E, for example, just for the, let's just put E here. I know it's incorrect. And let's just look for E here. Now, if I take that out, E is simply at index of 1. So if I run it, it will show me index of 1. So what if I want to see other E's in that? I can tell like as an argument here in this function index of from which character index you should start looking. So I can come here, for example, and put 6. I know J is at 6. So starting from J, look at the other E, and he's simply going to tell you the location of this E here if you do that. And it's at index 32. You can also look for not only one character, multiple characters. For example, TH. Where's the location of TH? Which it's going to show me the index of T specifically. And it's at index 12. And the same thing, I can decide from which character I want to go with. Now, the last method that we're going to talk about, which is what we call a substring. Now, substring is extremely important because substring is used to break down your string into multiple, to break your string into, to cut, let's say, a piece of your string. There's another method called split. The book is not mentioning it, but it's extremely important method because you can break down a whole string into words. And that is extremely important in Java programming. So I want you to go and dig into the split method because this split method was the reason that I didn't get a job. And that was way long time ago. And till this day, it hurts because I went to the interview and they asked me to write a program that would get something done. I got everything done, but I knew that there's a method called to break down a sentence into words. And I didn't remember the syntax of it. And they didn't allow me to use any references. So I have to do whatever I have in my mind. So I decided to create my own method to do the job. And my method get the job done, but they didn't like it. They said, you wasted a lot of time creating your own method where something does exist already. I told them I knew it does exist, but I didn't remember the syntax. So I didn't want to give you guys a code that doesn't work. That didn't help. So go ahead and read about this split method and learn how does it work. You don't know, maybe you'll be asked in an interview, how does it work? So I'm just telling you right now. Let's get back to the strings. I'm going to use this string here, and I want to cut, let's say, this part. Hello, JCC. So this is how we do it. Control V. And here's what we do. We do str.substring. Okay, and you put parentheses. Now, you have to tell me, very, very important, which index is going to be the index you're going to start cutting from. And in this case, I'm going to go with 0. And you also have to tell me what will be the last index that will not be included. This is very important to understand, not be included. So in this case, for example, I don't want the comma to be included. So I'm going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to put 10. Remember here, the last C that I have here has an index of 9. 10 is for this comma, and I simply will put the index of the last character, and that character will not appear in my string. So if I put it this way, you would notice hello JCC. So you just cut that part. Now, let's say I want to cut this part. All I need to know is what's the index of T. Now, if I don't know what's the index of T, well, here's the method that could help. So I'm going to copy this. And I'm going to put it here. And instead of TH, I'll just put single quotation T. Now, the question is, what will be the last character? The index of the last character. Now, I can count if I want, but I know if I put S, the index of S, which is supposed to be 31, I believe, then it's not going to appear. And I want it to appear. So whatever the index of the last character is, just add 1 to it, which is going to be 32. Now, of course, you don't have to put 32. If you want the index to this method to cut everything from T all the way to the end, just don't put anything here. And it will do the job perfectly fine. And here it is. This is a Java class. So this substring method is extremely important because, again, after all, again, it's very simple and very, very basic operations is to simply read a book and try to create some statistics about this book. How many times one word appeared, the frequency of the appearing of a single word in each chapter. If you want to break down the string into the whole book into paragraphs, sentences, phrases. So there's like an endless number of methods that or operations that you may want to apply to a text using those basic methods. Now, as I said, this is what the book that we're using is offering at this point. And again, I am pretty sure that more will be actually offered in the future chapters. So I just want to jump right now and talk about them. We'll just wait until that time comes. And the last thing I'm going to talk about, and then I'll let you guys look at the assignment, is that split method. So let me just go ahead and look for it so I can Java string split method. And here we go. Let me just, I need to share my screen, of course. Show me how, disable, okay. I'll disable it, 1 sec. Not what I wanted. How do I refresh in Java? Sorry, here we go. And here we go. So look at this. How do we use a split? Did he show it here? Where is it? Here it is, split. So whatever is going to be returned, I think why it's not mentioned right now, because what's going to be returned is going to be returned in the form of array, and we didn't talk about arrays, so I don't want to get you into this right now. This is way, way too early for it. So don't worry about it, okay? Just let's forget it. Let me go back here to let me stop sharing. Is there any questions? Anyone have any questions so far?
I have a question about the homework or the project that I was checking it.
Which
right
one?
now.
The
You
3?
just posted.
Yeah, that's
Right.
that's what I'm going next. I just want to make sure that we don't have
Okay.
anything here to talk about, so I can go and straight
Okay.
go to it. Okay, let me just go and jump to the project. So let me share my screen. And here we go. So project number 3. Now, project number 3 depends on your work from project number 2. Okay, so you can go ahead and download project number 2 and work and use it as a starting. Now, as long as you got the work, you're going to have to modify it. Let's just put it that way. Okay, now let me just open project 3. In project number 2, you were simply asked about a single satellite. So you enter the information of a single satellite, and you enter the length, the width, the height, the density, and then based on that, you were able to calculate the volume and the weight. Now, what he wants you to do, he wants you to start with start by asking the user to enter how many satellites he want to create. Now, this involves using loops. And the loops that you're going to be using are going to be for loops, because once you ask the user to enter how many satellites you want, you want to create 4 or 5 or 6 satellites. So you can use a for loop for that, because you know how many times you're going to be repeating the process. Once you figure out how many satellites, you're going to generate a for loop for it. And for each satellite, which every single iteration, you need to print the information as you see it here. Satellite number 1, enter the length, enter the width, enter the height, enter the density. So this information is going to be entered for each satellite, and then you're going to calculate the volume and the weight. And then after that, you go to the next iteration. So you're going to read the second satellite, and you're going to calculate again its own length, width, height, and density, and then you're going to calculate its own volume and weight. Now, here's the thing. Once you're done with all your satellites, you're going to have to show me what is the total volume and what is the total weight. To do that, all you need to do here is to create 2 variables, one of them for the total volume and one of them for the total weight, and assign them to 0. And as you go with the process, always accumulate the values for each satellite. Is that clear? And I think Ahmad had a question.
Yeah, so it's just the exact same thing, but in a loop.
Exactly. But you just have to remember here, you're going to have to create 2 additional variables, one of them for the total volume and the other one for the total weight. And you need to make sure you update those values at the end of each iteration.
Okay.
And you need to make sure also, very, very important, you can use a while loop if you want. That will work too. It really doesn't matter in a case like this. What you need to understand here also is, how am I going to print satellite 1 and satellite 2 and satellite 3? That's an extra step. But I believe by using your work from the last week, this will be a piece of cake. So let me stop sharing. I'm going to stop recording. And